Okay, hi, hello. We're gonna be looking at piecewise functions today and also parametric equations. This kind of questions usually always appears, so you need to be very careful. Okay, but these questions are generally very easy, and they come in lump amount of marks, like just 4 marks, 5 marks, and they even appear in 2024 A-level paper 1. So pay attention. Okay, yes. Number 1, we're going to look at piecewise functions. Just like how the name is stated, right? Piecewise. So in pieces. Okay, you're looking at functions in pieces. Okay? Yes. So if there's going to be pieces, there's going to be different parts of the curve as well, right? Okay? So just as what the definition is, which is a function that is defined by different expressions on mutually exclusive intervals. Okay, it means that it's non-overlapping. All right, yes, non-overlapping means it's totally different, right? Because they're not overlapping, just like your set notation. They don't have union lah, like, yeah. Okay, I mean they don't have any intersections, or yeah, you just union anything. Okay, first one, we're gonna look at this. Okay, x squared and 8 minus 2x, and then you have this. These are your domains. They're gonna tell you from which range is the graph applicable. Okay, so for your first type, you got x squared and then 8 minus 2x. Okay, this is your piecewise function. The moment you see two different equations, then they give you this domain and stuff, it is a piecewise function. Okay, firstly means that for the graph below x, and below 2 I mean, if it's lesser than 2, it's going to be an x square graph. It's x square graph, yeah. It means that it's a quadratic graph, right? This is what we learned. And then we also got, if it's more than 2, it's going to be a linear graph, which is, ax plus b graph, if you remember. Yeah, so this is that graph. Okay, so you got a clear idea now, right? I hope so. Okay, so first you got to plot this, then later you got to plot this as well. There is this function in your GC. You just need to actually take out your GC and then pause the video and then try this, key that equation in, because it's really important. Okay, number 1, sketch the graph of your fx. Okay, go to math. I hope you know where is math by now. It's already like 2 months in JC. Okay, so yeah, go to math and then go to this in your GC. Scroll all the way down there, you get this B thing in your GC which says piecewise functions. Yes, then go to second math to get your inequalities, and this is what is over here. Okay, to get your inequalities, so you're lesser than or equal to 2, and then you're more than 2, so you just key that in as well. Okay, also you will ask if it's 3 equations or 2 equations. In this case you got 2 equations, so key 2. Okay, yes, so if you get it, you get a graph like that. Okay, then this is your graph lah. Okay, so originally this curve was supposed to be like that, with this like that. Okay, but then since they have the domain which is only from 2, you only have this to this. You just basically cut away a few of the graphs. Okay, yeah, and also always label the intercepts and whatever these points are. Okay, yeah, this is like your maximum point, but it's like the point that they both are joining, so it's important. Yeah, and then also label your graph fx. Okay, yeah. Okay, second type, sketch the graph of y equals to gx. Okay, for this graph you got you got the same equations, but what has been different is this. Look at your domain, they got 2 now. Okay, so you're gonna be thinking like, oh, does this even make a difference? Yeah, it does, because this time you're going to substitute inside. What if they ask you not to use a GC? Because in your piecewise function, right, it's going to be very hard to identify the maximum and the minimum points over here. Like these intersections, it's going to be very hard, these things. So what you need to do is substitute inside these, sub, then sub your 2 and everything. So so your x squared is just going to be negative 3 squared. Yeah, when you substitute this. Yeah, you know what I mean. Yeah, same thing for below, 2 and then your 3. Okay, yes. So that's what I've done here, which is you sub in your first number 3 into the equation here, because this is only applicable for this. Like this domain is only for this. Okay, this domain is only for this equation. Okay, so you sub in your negative 3, you get 9. Then your negative 3, 9, you can just exclude, because you see here this inequality is not equal to, it's only this. Only if it's like this, then it means lesser than or equal to. Okay, so if it's lesser than something, it means that it's not included, right? Which is why it's an open circle to state that it is excluded. Alright, yes. This one, right, by the way, is to like draw dots here later. Okay, but just take note first. Okay, then now I'm gonna sub in 2. Okay, 2, then just 4, but then like you see this inequality, it says equal to, so it's gonna be your closed circles. Okay, yes. The rest of the other two, cover the answer and then try again. Okay, you don't want to cover up and try again, it's your problem. Okay, yes. Oh, by the way, these two, right, are continuous. See, got 2, 4 and then got 2, 4. It means that it's a common point. Okay, so later when you draw, these two must be together. Okay, so this one is what, excluded, right? So you see, open dot. Then this one is continuous, so you don't need anything. Okay, then later this one is included, because you see here, included. Okay, so 3 and then you put close dot. Okay, so very important. This one's the basics of the basics. If you don't understand, then go check one more time. Okay, next one. You got your modulus function here, which is this one. Okay, modulus, yes. So when you put modulus, right, whatever is inside a negative number will become positive. It's not going to become positive, but it gives you a positive value. Okay, so if you want to work backwards, you need to make sure that the graph has both the component of x and also negative x, because you never know what the number is actually, right? Yes. Okay, and this one is also going to be a very continuous number, right? Which is why one of them is included and one of them is not included. Okay, yes. So yes, as you can see, if it's 3, it's just going to be 3, but if it's negative 2, it's going to have negative 2, which equals to 2. Yeah. Okay, first one. Let's unpack the equations here. Okay, so x plus 3, right, can also be negative x plus 3, or it can also be positive x plus 3. So this is the first one, x plus 3, and this you see got negative, so this is the second one. Okay, so same for this, more than 0 and lesser than 0. Yes. Okay, because it's lesser than, you know why it's lesser than, right? Because it's negative. Okay, yeah. Then this one is just x plus 3. Yeah, it's the same thing. Okay, this is to get the value of your x, because this is the equation. You actually want to get the value of your x. So yes, you unpack it and then you get this. Yeah. Okay, this is try question. Yeah, express this piecewise function and then also sketch the graph. You can sketch it, then show me in class. You got 10 minutes to do so. So yeah, go do. Okay, hi, welcome back after the trial of the question. You can come and show me the answer for the question again. I'll go and check. Okay, let's look at parametric equations. This is also quite commonly tested. It will definitely be tested for your WAs. Yes, they will at least try to. Yeah. Okay, so your parametric equations, right, is basically another variable. So they bring in another variable, for example, v here. Okay, you got your y, you got your distance x. So this is your velocity. Okay, this is just an example, by the way. Okay, so you see the third variable, right, is x and y are basically dependent on it, right? Because what? Distance equals to speed times time. So they are all dependent on each other, right? If your distance is more, then the time taken would also be more. If your speed is fast, then your time taken will be less. You know all of these? So they're all dependent. Yes, dependent. Okay, so they're just introducing another variable into your graph so that it gets easier for you. Okay, yes, this is very important. Okay, try to make some effort to memorize this. Also come to class and tell me, okay, so that can remember lah, basically. Okay, first one is cosine square x plus your sine square x gives you 1. Okay, next one is your 1 plus 10x square gives you secant square x. Okay, the other one is your cotangent square x plus 1 that gives you cosecant square x. What do you realize about this? This one they don't really teach you in school, but if they do, then good lah. But like basically, if you differentiate sine, you get cosine. So the derivative of whatever, right, is actually inside the equation itself. You differentiate your tangent, you get secant. Then you differentiate your cotangent, you get cosecant. Okay? It's just the difference of your 1. Okay? But it can also be shown. For example, sine square, you differentiate, right? You get you can remember this as sine square equal to 1 minus cosine. Okay, sorry. Yeah. Basically what I mean is that sine square x equal to 1 minus cosine square x. Okay, then also this one, when you bring over the 1, is going to be tan square x. You differentiate, you get secant square x minus 1. So just remember, of course lah, you don't get minus 1, but like remember where the 1s go and if the the symbols of the 1s. Okay, I'm just giving you a clue for this too. I'm not giving you a clue for this. This one you need to make your own effort. Okay, then your cotangent, cosecant. Okay. Yeah. Okay, next one, to convert a parametric equation to Cartesian form. Okay, Cartesian form, you just have to make your, where is it? You just need to make your variables subject. Okay, t in this case. Yeah, this one very important, also not mentioned in schools. This is like a plan. Okay, yeah. Okay, to convert the parametric equation to a Cartesian form. Okay, first you need to make the variable t the subject. Okay, then you eliminate your t using your trigo identities, which is here. Okay, yes. So for example, right, your x equal to 3 cosine theta, then your cosine theta is just gonna be x over 3. Bring over the 3. Don't tell me you don't know how to do. Okay, because in this case your theta is your other variable. Okay, your x and y is always the these y-axis, your x-axis, which means that theta should be your other variable. Okay, t is just an example, by the way. Okay, So eliminate this, you need to make it the subject. Then this one also bring over. Then you get this. Okay? Then using your trigo identities, you just need to square because this is cosine theta. So you need to get cosine square theta, right? So you just need to square. Yes. Okay? Then this one also. I just rearranged it here, by the way. Okay? Then your denominator is the same. You get 9 and 9, so it's just like that. Okay? And this equation is your circle. Okay, so it's a center 0 0 because the coefficients are just 1 and 1. Then it's 3 units because 9 square, 3 square gives you 9, or rather square root of 9 gives you 3. Okay, done. Yeah.